Okay, so we're going to make a little chart up here at the top. Okay, so F, F prime, and F double prime. Okay, so F can be increasing or decreasing. It can be concave up or concave down. Okay? Then within that, think about that if F is increasing, then that makes F prime positive and F prime negative. Okay, or if you know concavity, remember that the slope of that is F prime, so if it's concave up, F prime would be increasing or decreasing. Okay, and then for F double prime, remember that if F is concave up, then it's positive and negative. So the main thing that you want to remember is that if F is concave up, you know two things. You know the second derivative is positive, and you know the first derivative is increasing because its slope is positive. Okay, then when F is concave down, you know that its derivative is decreasing, which is the second derivative. Okay? So we actually did one of these in class today. Take a little look at your graph. Okay, this is a graph of F prime of x. Okay, it says F prime has horizontal tangents at -3. So here, at 2, which is here, and then at 5, which is here. Okay, then it says, find all values where F has a relative minimum. Okay, look at your graph. You know how to do it. Where's the relative minimum? -1. Good. So you'd say there's a relative minimum at x equals -1 because F prime changes. Yes. Negative to positive. Now, if they had asked for critical numbers, what other numbers would you have had to list? Yes, and then remember that even if there's not a sign change, that still counts as a critical number. Okay, so even though it doesn't ask for it, just to review, okay, I'm going to put, there's a relative max where? At -5. I'll look for it in a second. And then there's a neither at x equals +5. Okay. Oh wait, it says it, boom, look, right here. Okay, so now read through part C and see if you can do it. Okay? Is it day 1 or day 2, Castle? Just on that sheet. Have you come to him before? Thank you. Okay, then just add your name and then just initial by today. Okay, so if I want F double prime to be less than 0, what am I looking for in the graph? The slope to be negative. Okay, if you put this, you're going to be wrong. Where's the slope negative? There's 2 spots. Okay, -7 to -3 and 1 to 5, or 2 to 5, yeah? Okay. They're cookies. Did you say cookies or brownies? No, that's not me. It's like, I think brownies if you're making them. Parentheses. Okay, but this is going to get you no points. This is why. -7 to -3, union 2 to 5. Okay, I'm going to give you a minute to think about, reread through the question, and tell me why that won't work. You don't need an x equals, and it's not a parentheses bracket thing. On the AP test, if you use a parentheses instead of a bracket or vice versa, they don't take off for that at all. Okay, what is wrong with it? Read the little thing. What does it say happens at 3? Okay, so at -3 there's a horizontal. What happens at 3? What is the slope? Oh, you can't Okay, what is the slope at 3? Undefined. So think about the question that they asked you. They said, when is the second derivative, which is really the slope, negative? If the slope is undefined at that point, does that count as negative? No. So you would have to break up. I'm going to fix it in my part C. You would have to break this up into 2 to 3 and then 3 to 5. And the reason why is because at 3, there's not a slope. It's undefined. And if there's not a slope, then it certainly can't be a negative slope. Okay, so that one was a little bit tricky, and they were strict on that if you didn't break it up that year, they didn't give you the points. Okay, and so then it would be because the slope of f prime less than 0. But if you had included 3 inside your interval, that would have been 8. Because the slope's not negative there since there's not a slope, since it's undefined. Okay. All right, turn the page. All right, next one. I'm going to bring you a little treat. Actually, I think, did we do this one in class today? Yes, we did. Skip it. Go to the next one. This one. Okay, you can do it. And I'm going to bring you a treat. Okay? Well, so think about it. If you're using parentheses, you're not including 3. So it's literally just specifically the number 3. That's an issue. Around 3 is not a problem. It's just at that one point there's not a slope. And if there's not a slope, then it can't be a negative slope. Absolutely.
I think we did this in class, that's what I was doing.
Left would be min. Yes.
Those are chew.
Okay, these are chewy. These are okay.
You look. Peer pressure down.
You want one? Okay. You're welcome. Okay, do whatever you can do, even if you can't do the whole thing. You want one? These are chewy. You want one? Do you want one? You're welcome. Now I'm going to these snacks. So yes. You do these snacks. Don't take those out. Here, take those 2 halves.
Wait.
Those are chewy halves with a normal cookie. It's like best of both worlds. You want one, Grant?
It's almost breaking.
I think it just broke when I transferred them to the same bottles. Because I try to like dump them so I don't touch them. They're chewy. I don't like it. I like the crunch. I just think it tastes good. Maybe it's because I burn all my food in there. I'm just a little more used to it. You don't like that? Okay, so question says find the time and the position when it's farthest to the left. Did it say relative? If it doesn't say relative, that automatically counts as an absolute. Now, if I want to be farthest to the left, are they asking for an absolute min or an absolute max? Minimum. Okay, so look at your graph. Where do I have a relative minimum? Okay, at 3. Okay, so I have a relative min at t equals 3 because v changes negative to positive. Now, second period we talked about this today, third period we didn't. We're going to talk about it tomorrow because of the copies. But if you have only one sign change, you automatically know that that one wins. Okay, do I have only one sign change on the whole interval? No. I have 2. That means you got to do a chart. So, time on the left, position on the right. Okay, the things that go in my chart are the times of the endpoints, which would be 0 and 6. And then my critical number, or my relative minimum, which was at 3. Okay? Now, go back and reread the question. What was my position at 2? Because I can't use velocity to find my position. What does it say? At time 0, the particle's at -2. So that tells me that at the beginning, my particle is 2 units to the left of the origin. Okay? Until 3, I accumulate all of this area. Okay, am I going to add or subtract that from -2? Subtract, because it's where? Now, how much am I going to subtract? Well, look right here. It says the areas of the regions from 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2. So that means that this one is 8, this one is 3, and then this one here is 2. So if he's already at -2 and then he goes backwards 8 more, where is he at 3? -10. Because I'd have to minus 8 from -2, right? Now, I didn't put 5 in my chart, but I'm going to kind of squeeze it in right there. Until 5, what happens? How much area does it accumulate? 3 positive or negative? Positive. So if I add 3, then where do I end up?
We get point count off when we didn't include 5 in the chart.
-7. You wouldn't have gotten points off as long as it didn't mess you up skipping it. Okay, and then for my last one till 6, I go 2 more negative. Where does that put me? -9. So when is the particle farthest to the left? At 3. Now notice, for this one it says, find both the time and the position. So this is one of those where it's best for you to say both. Okay, the absolute min is -10 at t equals 3. And then remember that if your chart is labeled and you have everything set up correctly, then you don't need an additional justification. Okay? Find your relative min, then set up a chart.
So in the chart, you like
Endpoints? Huh?
like the 5. Is that
The only reason that I went back and put 5 is because I wanted to remember that I went forward 3 and then backwards 2. So it still turned around at 5, and I didn't want to skip over it and forget the 3. So it wouldn't be wrong to not include it. You know it's not going to win because it's a maximum, right?
do we have to say relative min at t equals 3?
I don't think that you would have to, but I probably would anyway. But I think that you'd be okay without it. Okay? All right, go down to the next one. It says, for how many values is x equal to -8? How many values would that have to happen from 0 to 6? How many? Yes. Because why? What theorem says that? Nah, kind of. Okay, it does say it's IVT. Good. Now, continuity is a thing. If it's differentiable, what is it also guaranteed to be? Continuous. And if it's differentiable and it's continuous, then IVT says you can't skip. So if I go from -2 to -10, I hit -8. Then I went back down to -7, I hit -8 again, and then I hit it a third time right here. So for how many values, you would say 3 times. Okay, then for your explanation, you would say V is differentiable. So also continuous. And -8 is between, I'd say x of 0, which is -2, and x of 3, which is -10, and x of 5, which is -7, and again, really you could probably not write all of this. I don't know exactly what you'd have to say. Okay, but you're basically just saying -8 is between the y values on this interval, and this interval. Okay, and probably if you shortened that a little bit, now would you have to state that it's continuous? Yes, and then we would also have to state the name of the theorem, which I forgot to do. What guarantees this? So IVT.
If we put it That says continuous. So would it-
I think you should say it's continuous.
No, I'm saying like if you forget, like, would they count as wrong?
They could, because even though if it is well, I don't know. I would say I'm not sure on that. I'd probably say it anyway, just in case, but
Just above.
yeah, I would say because it's differentiable, I know it's continuous. Because you have to think about the theorem requires it to be continuous. But maybe they'd give it to you anyway, I don't know. Yes.
First one, why do you, so it's an absolute, like they're asking for absolute minimum,
Uh-huh.
but like when you write the answer, you put relative minimum.
Okay, so this is my answer.
Oh, okay.
Yeah? So I was saying here, like, I'm picking 3 because it changed negative to positive. But then when I realized I was going to have to set up my chart, that's where I was like, okay, well, this is not really my answer. This is the main answer right here to answer the question. Okay? And then the other thing I do want to point out, I think I said this a minute ago, but if it doesn't say relative, it means absolute. Okay? Or if it says local, that's the same as relative. Okay, so go down to part C. We covered speed, I think, maybe last week. How do you tell if the speed is increasing or decreasing? What has to be true? Velocity and acceleration. Good. Now, velocity and acceleration are both in this graph. Velocity is the y value, and then acceleration is the slope. Now, remember that they can both be positive, but they can also both be negative. So, look at your graph. I'll give you a minute to think about it. You need the y value and the slope to have the same sign. Okay? So if I'm coming up here to my velocity graph, I start off below. To match a negative y value, I would want a negative slope. That happens until 1. But then from here to here, my y values are negative, but my slope is positive. That's not going to work. Then from here to here, I'm above with a positive slope till 4. Then I'm above with a negative slope. That doesn't work. And then from here to here, I would be negative. So it says from 2 to 3, what's happening? Well, 2's here, 3's here. So what's our explanation? Increasing or decreasing there? On 2 to 3, this little section of your graph. Decreasing, very good. So we would say on 2 to 3, speed is decreasing. Because v of t is less than 0, but a of t, the slope of v of t, is greater than 0. Okay? So my y values are below. That means my velocity is negative, but my slope is positive. That's my acceleration, so it is decreasing. Okay? Then last part E says, on what intervals is the acceleration of the particle negative? Acceleration is what in the graph? The slope only. So look at your graph. Where do you have a negative slope?
0 to 1 and 4 to 6.
Good. 0 to 1 and 4 to 6. And then remember, just like on that other question, if it had had a vertical tangent, you would have had to break up around that spot, because your slope can't be negative if it's undefined. So because slope of v of t is less than 0.
So it's just vertical tangents, not horizontal.
Horizontal tangents don't matter. Okay? All right, turn the page. Okay, take a look at the next one. Got it? Okay, we're gonna need calculators for these. Do you have a calculator? Okay, we're gonna skip. I'll pass out calculators. Look at these last two. Skip that page, and I'll bring y'all some and see what you can do on these. Okay, work together if you want. If you have your own calculator, go ahead and take it out. And if I don't see what I'll bring you. Yeah. No questions so far? You need one? For the other page now? Got one. You need one? You need one? Jack, you have one back there? Okay, we did these like a super long time ago. Do we remember anything? How can we eliminate easy answer choices? Yeah?
Since the slope is greater than 0, that means they should be getting, the numbers should be getting bigger.
Okay, good. So if f prime is positive, f needs to be increasing.
And then if,
So which ones can we eliminate based on that? Okay, C only? Okay.
and then the next one is basically saying that they should be getting bigger with a smaller amount.
Okay, good. So that would be concave up or down if it's less than 0? Down. So draw a graph that's increasing and concave down. It would look like that, right? What is happening to the steepness of the graph if it's increasing but concave down? It's going to be getting flatter. Okay, so what he said is perfect. Your jumps between your y values should be getting smaller each time. So if I look at this one, 7 to 9, that's plus 2. 9 to 11, that's plus 2. 11 to 13, that's plus 2. That's basically linear. That's a straight line. Okay, because the jumps are the same each time. But when I look at B, 7 to 10, that's a jump of 3. 10 to 12, that's a jump of 2. 12 to 13, that's a jump of 1. And so that graph is getting flatter. That's what we want, so it has to be B. Now, D would have been the answer if it was the same sign and it was getting steeper. Okay? Or if it was concave up. Yeah. Okay, look at the next one. Look for your easy eliminates. Okay, lots of random stuff here. Oh, yeah, yeah. Okay, what's the easiest one to eliminate if we know it's continuous? Okay, D automatically is out. Okay, then f prime of 0 is not allowed to exist. So what does it have to have there? A cusp or a corner or something, right? So if f prime doesn't exist, that means I need a cusp or a corner, cusp or a corner, cusp or a corner, so C is out. So we're down to 3 left. Then it says f prime of 2 is 0. What does a 0 slope look like at 2? It would have to be flat. So 2 flat, that one's good. 2 flat, that one's good. And then 2 flat, that one's good. Okay, and then it says f double prime has to be less than 0. What is that? Concave down. Now, notice it says except at 0. You can't have concavity at a corner, so that's why. Okay, so looking at my graphs, does this one have a concave up section? Okay, yeah, these are both out because this is concave up, and then this part is concave up. So it would have to be E. Good. Okay. Let me have you, just while we're on it, do the next two as well. Okay, so look at what's in the chart. The chart is V, that's the same as F prime, right? And it's asking you which of the following could be the position. Okay, what are my two easy, actually there are a couple different ways, but what's one way we could eliminate some answer choices?
F the origin.
Okay, origin, what is f prime at 0 supposed to be? So I need a -1 slope right off the bat. It has to be a -1 slope, not a -1 y value. So what's my slope here? Positive, not going to work. Positive slope, not going to work. That one kind of starts off negative. That one starts off negative. That one starts off flat, so that's not going to work. So we're down to 2 left. Then out of those two, what's another easy way to eliminate? Okay, at 2, my slope is supposed to be what? Or wait, you said at x equals 2 or at x equals 1? I would check at 1 here. What's my slope here? It should be what in the chart? At 1, the slope should have been 2. What's the slope here at 1 though? This is a 0 slope. So v of 1 there is 0, and that's not consistent with the table, so it would have had to be C. And notice that if you look at 1, you have an uphill slope, so that makes sense that your v of 1 would have come out to be 2. Okay, look at that last one. Okay, it gives you h of x up here at the top, and then it's asking you which of those could be h prime. Okay, so I'll give you a minute to think about it. Okay, anybody have easy eliminates? For me, I think it's a lot easier to look at the derivative. So if I'm looking at this one, remember this is supposed to be a graph of h prime. So if my sign changes like that, what should my graph have? A max or a min? How does it change? It's from positive to negative. This would have to be a max. Look at your graph. Does it have a max over here? No, not going to work. Okay, look at B. What kind of critical number do I have here? A max or a min? That's a min. Because how does it pass through? It goes from negative values to positive values. Then look at your graph. Does it only have a min on this side? No. So you have to remember, these are the h primes. Okay, now look at C. This one has a min and then a max. So look at your graph. Is it a min and then a max? That's backwards. It has to be the max first, the min second. So if I look at this one, that's the right order. And then if I look at this one, that's the right order. Now, the only difference between the graphs is at the ends. So look here at this one. My slope changes sign. If this is h prime, what is the slope of h prime called? H double prime, which would be concavity, right? So this would mean that my concavity has to change. Does your concavity change in the graph on close to the ends? No, so it has to be E. Y'all get those mostly? Okay, Cassie. Yeah? Okay. So on the ends here, the slope changes. And the slope, okay, yeah, just show me your pocket tomorrow. The slope is h double prime, which is concavity. So when I look up here, I notice I don't have, it's up the whole way through. And this side is down the whole way through. So if my ends are going to change direction, think about these would be like your x's where your concavity changes. And I only have one change. It goes from down to concave up. It doesn't change 3 times. Okay? All right, so let's rewind back to the one that we skipped. Okay, you have f prime of x here. Says, where does it have a relative max? So go ahead and type that in. Okay, notice they already gave you f prime, so you don't even actually have to take the derivative yourself. They're already giving you the derivative automatically right off the bat. Okay, and then you're looking for a relative maximum. Relative maximum. Okay, so my graph kind of goes up, down, up, right? Now remember, this is f prime of x. Okay, so where's our relative max happening? Which of those guys? First, second, or third? Okay, what kind is this one? That's a min. That one's a max. That one's a min. So make sure that you're picking the right one. You want to find that intersection. Okay? So I'm going to do second trace here. We want the 0, which is the x-axis. And then I'm going to go a little bit to the left, then a little bit to the right, and then find my 0. And remember, you just want to kind of trap it on the inside. So 0.9100, which is answer choice C. Got it. Okay? All right, take a look at the next one. Notice they already gave you f prime. Go ahead and type that next one in. This time they're giving you a specific window, only from negative 1.8 to positive 1.8. So sine x to the 3 from negative 1.8 to positive 1.8. Okay, so looking at your graph, it's asking you for points of inflection. Okay, so if this is f prime, what is f double prime for the points of inflection? What will that be in the graph? F double prime will be the slope. So look at your graph, put x is where your slope changes, and then count them up. So I want a slope change. It goes from up to down, that counts. Then it goes from down to up, that counts. But then notice that here, it gets kind of flat, but then it stays uphill. That doesn't count. And then I have another one here, and then I have another one here. So you have a total of 4. Okay, take a look at the next one. Okay, you have your f of x this time. Notice they did not give you f prime. They're giving you regular x. And they're asking you where it changes concavity. Okay, in order for you to do that, you have to be looking at least at a graph of f prime. So you can't graph that one. You need to find f prime of x. So what is the derivative of cosine 2x? What would that be? Negative sine 2x times 2. That's your chain rule. And then what's the derivative of ln of 3x? It'd be, no, 1 over 3x times 3. Remember, what's the derivative of ln x? It's 1 over x, right? So the derivative, I'm going to write it right here, of ln u is 1 over u times u prime. So I'd have 1 over 3x and then times 3. So this is what you're going to graph, not the original, the derivative. So go ahead and type that in. They did not give us a window, so we're just... It is 1 over x, but it won't always work out that way. But you're right. For this one, the 3's do cross out. So I have negative 2 sine 2x plus 1 over 3x times 3. Or you could eliminate the 3's if you want to. That would be fine. Okay, and then look at your graph. Okay, so doing some weird stuff here. Okay, it's just going up and down and up and down.
Zoom in or something.
I did it. I'm looking at just 10 to 10, like the normal window, like that. Zoom 6 on yours, the standard window. The other option is you could be in degree mode. Does y'all look like mine or like? You know what? I know what I did. Okay, look. Let's see if you know what I did. What is it? It's with the fraction-y part. What did I have to do with the 3x? You would have had to put it in parentheses, or you could have used the fraction bar. Either one would have been fine. Okay? No, you're right. Mine's wrong. I'll just retype it. Okay, so look at your graph and then find the concavity change. Negative 2 sine 2x. Dang, and I already drew this ugly picture. Plus 1 over x. Okay, so it is asking us for the least value of x at which the graph of f changes concavity. Okay, a couple of things that are tricky here. The first thing is that this is a graph of f prime. So am I really looking for a point of inflection on this graph? No, I'm looking for where my x's go. So I've got a bunch of x's, right? I have them here, 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 here. Here, 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 etc., right? So there's a whole bunch of them. So how can I have a least one? Okay, think about your original function. It had a log in it. What does a log do for numbers less than 0? It's undefined, right? So that means that this entire half of the graph where x is less than 0, okay, it exists for the derivative, but if it's a log graph, that means that x can't be negative anyway. So this entire side of the graph over here is basically eliminated, okay, to the left of the x-axis, because you have an ln in your graph. None of that counts. So then now, do we have a least value? It'd have to be that one. Okay? So remember, your points of inflection on f prime are really the turn points where the slope changes. Okay? And then you could zoom in if you needed to, second trace. What are we looking for out of our list if we want this low point? We want the minimum. And then for my left bound, I would just arrow to be a little bit above it, and then a little bit on the other side of the hump. And then guess, nobody cares about it. So 0.93, which is answer choice B.
So the smallest ln that you can do is 1.
No, it's 0. And actually you can't plug in 0. It has, so at 1, the graph of ln changes from positive to negative. But it still exists. It doesn't exist on the other side of 0. Okay? Alright, last one we're going to do is this one. And I don't even really want you to do it, I just want you to set it up. Okay, we did one like this, I think, in both class periods. Okay, you have acceleration, you have this random equation. Then it says the velocity of the particle is 2 at 1. The velocity of the particle is 2 at time 1. Then the velocity of the particle at 2 is, what are they giving us? The want have thing. So I have it at 1. I want it at 2. So then remember, I'll start with 1 plus, and then I'll integrate from what I have to what I want. Then also remember that if this is going to be acceleration, does it make sense that I'd be putting a of t inside the integral? Okay, yeah, because remember that whatever's in your integral is always supposed to be the derivative of what's outside of it. So if these are velocities, that should be acceleration. If these are positions, that should be velocity. Okay? And then you don't have to do it. Okay, good job. Mock exams tomorrow, most of you. You're going to do so great.